Now, we did need to stop and, make sure we understand how to use the distributive law, right?
Mm-hmm.
And we did that just fine. You saw that this was x plus 3 times x plus 2, right?
Right.
And then you multiply that out. And there are two ways to do it. I could do x plus 3 times x plus 3 times x plus 3 times 2, or I could do it as x times x plus 2 plus 3 times x plus 2, because the distributive law works on either side, right?
Right.
So this gives us, and I'll just write it out. I'll go ahead and write out the x squared. Right?
Mm-hmm.
Just another application of the distributive law. And that's x squared plus 5x plus 6. Now, you factored this one correctly, and you verified it the same way. Wrote it out. And I want you to do that with the problems I'm going to ask you to do for next time that I'll post on the website, okay?
Okay.
Okay. I don't want to post problems. I don't want to decide what I want to assign you
All right.
until I've worked with you, because I might assign you something you don't need at all, or I might assign you something that's too big of a jump for you,
Okay.
okay? But I'll try to assign something that's very similar to everything we've done here, okay?
All right.
Just different expressions. And then later on, because you seem to be, pretty good at this.
Oh, thanks.
I might challenge you a little more once in a
Yeah.
while, okay?
All right.
Because you learn more that way.
Yes.
But if I challenge you too much, you just sit there, beat your head against the wall, and you
Yeah.
start forgetting stuff because your head hurts. Okay, anyhow, we get here x plus 3 times x plus 1.
Mm-hmm.
And you verify that, okay? And over here, you get x minus 3 times x minus 1. Okay? Okay, well now we're going to have to add these fractional expressions. We call these rational expressions because it's like a ratio of a numerator to denominator. When you get away from numbers, we'll call them rational expressions, but they're just fractions with symbols.
Okay.
Okay?
All right.
So let's see, we got to have what do you have to do to add two fractions? You got to have a common denominator.
Right.
So we ask the same questions we did with the previous example. What's this denominator got that this one ain't?
Positive.
Everything.
Right.
Everything here is not here, right?
Yes.
So in order to get a common denominator, we're going to have to take our x minus 3 times x minus 2 over x plus 3 times x plus 1 and multiply that by x minus 3 times x minus 1 over x minus 3 times x minus 1, right?
Right. Okay.
Now, we have a denominator that contains this one as well as this one.
All right.
And we don't have any more than we need, right?
Mm-hmm.
Like, if this one had something in it that this one also has, we wouldn't have to include that because it's already over here.
Yeah.
Okay? So now, and then I didn't leave myself enough room, I tried. We have our x plus 3. I'll just write smaller and write neatly. Maybe we can read it. I'm not going to have room. Okay. Rather than write it so small, no sane person would want to read it. I'm going to just kind of extend it here, right?
Okay.
So there's our second term.
Mm-hmm.
And then what do we multiply that by? Well, whatever's over here that isn't over here, right?
Right.
So then that's x plus 3 times x plus 2 times x plus 1 over x plus 3 times x plus 1, right?
Right. Okay.
Okay. Well, now what? Well, it looks like what we've got now is x minus 3 times x minus 2 times x minus 3 times x minus 1, that's a 3 there, it's hard to read, okay? Plus all this, x plus 3 times x plus 2 times x plus 3 times x plus 1. And it's all over the same denominator now, so we can just write it all over that denominator. Okay? Now, one reason I forbid cancellation is because people will now say, oh, look, there's an x plus 3 and an x plus 3. Let's cancel them.
Yeah.
Can't do that.
Because that's what I'm thinking right now.
You can't do that.
Okay.
You can only do that if you've also got an x minus 3, plus 3 in this one.
Okay.
So that's a kind of a hard rule to remember if you don't know all the principles.
Right.
That's why I don't allow cancellation in my course. Okay? Well, at this stage, what we have to use a distributive law to multiply this out and multiply this out. Okay? We keep this factor just like we did with the fractions.
Okay.
Because then we put all this together into one expression and try to factor it. Well, lots of luck.
Yeah.
Okay?
Yeah.
I would have a lot of trouble factoring it, okay? And I know some tricks that you don't, okay? Now, there are people that are better than I am at it. Maybe they can see it a little quicker. But I doubt that what we get in the numerator is going to end up factoring. But what you have to do with the numerator is you have to apply the distributive law again and again and again, 4 times. Well, 3 times, okay?
All right.
No, 4 times. Okay, more than 4 maybe. And it's a mess.
Yeah.
And we're not going to complete this because I'm probably never going to ask you to factor a 4th degree polynomial.
All right. Thanks for
Okay?
that.
And I don't think you're likely to be asked in your pre-calculus class, okay?
Okay.
I'll just say now, factor the mess and see if anything divides out. And that's doubtful, okay?
All right.
Okay, very good.